Well, thank you for staying in the room. I know it's kind of getting hot. First, let me tell you that I made a terrible mistake on Sunday. We were in that room at the party, and the music was loud, and I made a mistake of speaking over the music at the table, so I almost lost my voice. So I've been recovering it since then. So if I go slow or soft today, it's not because I'm not excited to be here or present. It's just I'm trying to make it through 30 minutes, so bear with me. So I'll try to make it worthwhile for you. Thank you. So who has heard of Orleans before? Oh, nice. Who has played with it at least? Okay, handful of people. Okay, so my plan is to give you an overview. It's not enough time to go to good depth, but to give you an overview, an idea of what it's for and what problems it solves, so you can go and learn more through the resources that are available. And then the second part, I want to kind of reflect on how we arrived to where we're at, and especially from the open source perspective, what matters, and the lessons that we've learned. So the technical part I presented many times, so there are longer talks and more materials. But the second part I've never presented before, so it's first time and for you to judge. So Orleans started a long time ago when we were in Microsoft research, and sort of it was clear that cloud was coming, and this idea that you can get these resources from somebody else, kind of have a credit card and then run computation at any scale. That was obvious that it was coming. The problem we saw was that programmability was a little bit harder. And to say a little bit, it's another statement. Programmability was a really difficult part of moving to the cloud, and still is. Like, for example, who enjoys debugging concurrent code, multi-threaded code? Okay, so a couple of people, I think they're lying. I mean, it's fun for a while, but in the end of the day, you're wasting a lot of time. But then who enjoys doing that across a set of machines, the servers, a cluster of servers, figuring out? Okay, there's still the same two people there, probably on the fringe. So at Microsoft, we had big services running on the cloud for, I don't know, a decade at least before that with the MSN and what became Bing. So we had these expert developers, and we refer to them as Einstein developers. But the larger pool of even internal Microsoft developers were not in a category. They were good software engineers that could build applications for a single machine or a single process. And the goal of the Orleans was how do we enable these people to be successful in the cloud? So there is one obvious solution. By the way, these words in italics, I reused slides from some of my talks, and at the time I played name the tune with the audience, so if somebody guessed the name, I would buy a beer for them. So I just reused slides, some of the slides, just like code reuse, because why not? So I left them there. Don't worry about them. Just some of my favorite tunes. So we can hire these expert developers, but there's really few of them naturally. And they're very expensive. They all enjoy good jobs, or they live where they want, and it's very difficult to lure them. And you have to pay a lot of money for them, and they are very picky. But even if you manage to hire them, that doesn't really prevent you from making costly mistakes. Those expert developers, they still have to rebuild the systems that they build for certain scale when the scale goes up. When traffic multiplies 10 times, oftentimes you have to do and re-engineer a system. If it multiplies 100 times, you essentially throw away. That's been the history of all successful, or nearly all successful major web properties. So we need a better solution. And I discovered these slides from, I think they're from 2010, where there's some initial ideas of Orleans are being discussed. And you may not see here, but there's a DC#. We're even discussing building a language for building such applications. And if you look at this diagram, it's hard to see, but there was cloud part and the client, and there was Orleans runtime stretching and connecting both. We already had notion of grains. But sort of the view of this was very ambitious, and Azure at the time looked like a bunch of dishwasher machine, I think. So we worked, and here's what we ended up with. After iterations, learning, working with internal partners, this is the gist of the Orleans model. Think of it as a system that supports distributed unlimited pool of objects. We call them grains. Technically, they're actors, but a lot of people that don't know about the actor model, they get confused with the term. They imagine like Hollywood actors, or think of them as objects. So there's objects that live somewhere, and these objects implement interfaces. We call them grain interfaces. In this case, it's iUser that extends the marker interface. And one requirement for these interfaces is that all methods on those interfaces are asynchronous. They return a TPL task. In this example of Hello World, it returns a task of string. So sometime in the future, you get a string back. We're all familiar with TPL, right? Everyone's familiar with TPL, with task parallel library? Task sync await? OK, most people. So this is the most important part. How do we get the grain? The first line on this second snippet, we call a factory method and say, give me a grain that implements this interface, and we pass a unique identity of that grain. So for user, it can be user ID, and you decide as application developer what to use as identity. You can use emails, you can use GUIDs or ZUIDs or PUIDs, whatever. So it's application's decision to use a GUID or integer or a string or a combination of them. And the moment you call a getGrain of a particular interface and pass an ID, you get back effectively a proxy object for that grain. And then, because that proxy object implements the very same interface, so what we get back here, you see it implements iUser input var, just to highlight that it returns iUser. We can make a call right away. And because the call is asynchronous, we can just await and get the result sometime back. This whole magic of async and await works. When you implement a grain class, you just extend the base class grain, and you implement one or more interfaces, like grain interfaces like this. The cool part of this is that any method that executes, any method of an object or of an instance of the grain executes, always run on a single thread. So you never have concurrency. You never have to deal with locks or semaphores. So here we can increment the counter safely. It's a private variable, but I don't have to put any protection here because of the guarantees that the runtime provides. So see, we get a proxy object, and we make a call. We never create an object, and we never delete it. And that was a key insight that happened kind of sometime down the road. Because what happens under the covers is this. A grain is the logical object. It has this life cycle. Most of the time, it spends nowhere. It's just there is some persistent state of this object, of this grain, that somewhere in database and key value store, whatever you want to save it, maybe in the file. And when there is a request, when we call a method, like here, we call say hello in this grain, the runtime understands based on identity of the grain that it needs to create an instance of this object somewhere on the server, loaded state, so it goes through the activation process and stay active in memory for a while. But if there's no work for it to do, if no requests are coming, then it gets deactivated and removed from memory. So this is the key concept of Orleans, really. The difference is that it runs on a cluster of servers. So this is familiar diagram with two boxes with errors and storage, right? Remember from the Sunday talk, nothing's changed, right? You still have front ends, you still have middle tier, but the middle tier here is this kind of shared address space where these objects, grains, live. They're all individually addressable, but they can also talk to each other. The other thing that sort of is derivative of this cycle that I showed is that at any point in time, you only use resources of your cluster for objects or grains that are being used or recently been used. For example, if you have, say, 100 million users of a mobile app, only a small fraction of them are running the app at the moment, or a small fraction of those have anything for the app to do. Like if you're on Twitter app, unless there is something, there is notification, it doesn't do anything. It sleeps on the phone, even technically it's running. So by making these allocation decisions based on the load, we have automatic resource management. So only a small window, a sliding window of objects is in memory, even though the whole set of objects is addressable as if they're all in memory. That's the key insight of Orleans, and technically it's called virtual actor model. The other consequence of that is that because this middle tier runs on the cluster of servers, which as a programmer, as you saw in the code, we didn't talk to servers, we didn't have IP addresses, we didn't use any URIs or anything. So it transparently runs on the cluster of servers. The Orleans runtime also handles server failures. So if one of these servers was to go down, and the most frequent reason for it to go down is that Azure decides to deploy a patch for like a WannaCry update or something, then the runtime realizes we lost the server. It realizes what grains were activated on the server that we lost them, and then can reactivate them on other machines transparently, so you don't have to handle server failures at all. And if the server comes back later, the grains can be placed on it again. So that's the other big benefit, that it handles not only resource allocation, but also failures for the application. This is the more advanced scenario where you have a kind of social network relations. So you want to have grains, users that can make friends with other users. So if we look at this line, what we do, we called the one grain reference me, we call the method on it add friend, and we pass another reference as an argument. And this is just fine. But notice try catch. And it's here for a reason. So we pass the argument, but it can also handle exceptions. And to illustrate it, look at this picture. So the request arrives to the web front end. It calls first grain, grain A. That grain A may call another grain, grain B, which can be run on a different server, which in its turn can call grain C. All happens as if it's the same memory space on the single process. You program is like that. But if C throws an exception, if this method that got invoked throws an exception, and if there is no handling of this exception gets delivered back to the caller, in this case, grain B. And if B doesn't have any try catch, it'll automatically get delivered to its caller, grain A, and then all the way to the front end. So if you do nothing, you get the exact same semantics like try catch, but it's distributed in the synchronous. So that's also a very important feature because it removes a lot of code that you need to write. You can put error handling logic where it belongs, for example, at the front end, where it can give a user a meaningful error, but you don't have to propagate the errors by hand. So I could go and talk about all these features, but just for the sake of time, I want to mention that there's a bunch of other features, and this is just top-level ones. For example, the notion of virtual streams, which works the same way. By knowing the identity of the stream, you can subscribe to it, or you can produce a stream at any time by just saying, here's the ID of the stream that I'm interested in. There's many more features. Here's the takeaway for the technical part. So if somebody asks you what Orleans is, one sentence or two-word answer is distributed C#. So it's even shorter than the elevator pitch. If you're not running with exec in the elevator, but you're getting in the elevator and the exec is leaving, you have time to say distributed C#. Orleans is distributed C#. It's not technically 100% correct, but that's kind of what it is. The longer answer is, as we have it in our documentation, Orleans provides a straightforward way of building distributed high-scale applications. And if you go to academic paper and then publish a paper, then the tech report, it's distributed virtual actor model. So you can go and read all of that. The other takeaway is it's a mature code base. It's been running in production since late 2011. And there are several services within Microsoft, but there are many companies outside of Microsoft that are using it since then, since we published it. So the innovation doesn't stop. Right? So we keep working with research in particular, even after we moved the project out of MSR into, we call research MSR, internally moved to product group. Like, this is one example. We added geo-distribution feature where, if you look at this picture, this is how the cluster runs. In the normal case, you have a bunch of machines that automatically join into a cluster. But we support now the model where you have clusters deployed usually to different regions, different data centers, and they form what we call multi-cluster, but the program model stays the same. Plus, we added another option for replicated grains. We're about to release, in a matter of probably a few weeks, support for ACID transactions. And if you ask people, what about distributed ACID transactions, they will say it's a bad idea. So I would claim that we'll prove them wrong. We'll prove that it actually works and actually scales, and it provides a lot of benefit for our application. Just like we proved that the RPC, I claim, we prove RPC model works and distributed objects works with Orleans model in general. There are other things that we work with MSR on, with Unixes and things that we just need to integrate. The title of the talk mentioned actor-oriented database. I didn't come up with the term. So Phil Bernstein, no less, came up with it. And if you ever studied transaction at school, I'm sure you use his book because he's like one of the creators of ACID transactions to begin with. So he's a great collaborator on adding these features and doing kind of advanced research. So I didn't make it up. We open sourced Orleans in January 2015. And it's been going really well. If you follow Matt Warren, he's like one of the contributors to .NET and kind of performance-obsessed guy. So he ran these scripts back, I think, in November. Yeah, it's late November, across .NET Foundation repos, and he sorted them by percentage of community contribution in terms of issues and pull requests. And to our surprise, to my surprise, we were at the very top. So C Orleans is number 2, number 1 in this list. It's even cooler that it's very rare that other companies go and replicate what Microsoft has done. The perception is that Microsoft is a fast follower, has been over the years. But in this case, we have a JVM clone of Orleans called Orbit. The Proto-Actor project that Roger Johansson, who was a co-creator of Akka.NET, started recently, he has explicitly virtual actor model. They call them virtual actors there. And just recently, another project was introduced called Erlang. That's the Orleans model in Erlang, which completely blew me away because Erlang was the first kind of production quality implementation of actor model. So we made a full circle, and now there is Erlang version of Orleans. And I'm saying that because when we just published Orleans, we went out with the paper and the preview and the code, the initial reaction was kind of very, I would say, unwelcoming. Because people were saying, that's not an actor model. What you implemented makes no sense. It's not an actor. So it took us time to kind of discuss it and convince people that actually this model has a lot of value. And it's different. It's not what you're used to, but it doesn't mean that that doesn't work. We have a very, I would say, welcoming and thriving community. So in this case, like we have a Gitter chat, and people are there almost like 24/7. There are always people in various countries and various time zones. We do periodically community meetups, and they all record, they're all published on GitHub. What's interesting is that people in the community contribute in very different ways. I think it's a very short-sighted to look for just issues and pull requests, and special pull requests, specifically as a way to measure contributions. This whole meetup idea was started by Richard Osbury, who is in the UK, and he's Ryan still. His company is not using Orleans. But he did that. He built an HTTP dashboard to Orleans as NuGet packages that add a couple lines of code and you visualize what's going on. He realized that our docs were locking, and he did a lot on the doc side. We have another contributor. I believe he's in Ukraine, Dmitry. He submitted a series, I would say like over 20 PRs, and they all focused strictly on performance and improving throughput. And we counted with just his PRs alone, we improved our throughput by, I would say, about 80%. Just single guy who just pushing and doing it. We've never really talked with him in person. I think he's very shy, like even in the meetups, he doesn't say much, but his contribution is so enormous on the performance side. Then we have like Gutenberg, who's in Brazil. Like over the weekend, he submitted 80% of a module for support AWS because his brother, who's running another company in Brazil, they can only run on AWS, and he wanted him to use Orleans. Just push it. Here's a PR, a set of PRs to support AWS. It's done. But he's also in Gitter all the time, and he's helping people with basic questions. They can be Orleans related, they can be Azure related, they can be Docker related. It seems like he knows everything, and he's there like the whole time. It seems like he has no life. So very different ways to contribute, and we value that and appreciate. So this is the part they actually want to talk about, in addition to the technical. So it's interesting, there is some kind of correlation with what I think Ted talked on Sunday and what Sarah talked earlier today. A lot of what we learn, what I learned personally, I phrase it as software engineering is actually the people's business. We think of it as a tech, but actually it's more about people and interactions. And it's even more obvious when you go open source. And I think the other thing is important is that we, as humans, we don't control everything that we do. Like there is this whole science, and I'm not a neuroscientist, but I know that there is this Initial reaction, you have no control. Like I could talk about the amygdala and prefrontal cortex. I'm not a neuroscientist, but there is this thing that the first reaction you can control the second reaction. And by doing certain tricks, you can train your brain to do that. Instead of jumping and arguing on the first reaction, you can train your brain as a neural network to react better a second later, a minute later, a day later. And this is a set of tricks that I try to formulate that I think are useful. Well, you're to judge. The most important thing, I think, when you work on the project in general, and open source in particular, is to remove egos intentionally. We all have egos. We all have kind of opinions of themselves. We all view the world subjectively. They're never objective. And the tricks to do that, some of the tricks we learn over the course of the years is remove all things like my code. The moment code is committed, it's our code. You never say, this is my component. No, it's not your component. It's in the code base. It's our component. So by using this wording, you keep reinforcing that there is no pride of ownership. The fact that you wrote this code doesn't matter. Same as, like, it was mentioned about dissent. That dissent is important. But equally important is to, once the decision is made, even if you disagree, it's our joint decision. We may have made a mistake, but we discussed and the decision was made at the time. So it's important not to keep going and say, well, it's going to fail because I told you so. It's a very interesting balance. And it's very tempting when something fails to go and say, told you, see, I told you it's going to happen, it happened. It's very tempting for us to prove that we were right. So it takes an effort to refrain from them and correct yourself. It's tightly related to defensiveness because we're all actually insecure in many ways. And our first reactions to defend, our code, our pull request, our comment, it's very natural for us to do it. So the important thing is to realize, yes, this is my first reaction. I try to defend myself. But then you step back and say to yourself, is it my first reaction or do I have to look at it objectively? The trick sometimes, like the tell is like, oh, let me explain it. So you give me a comment and I'll explain to you. That's usually tell that you're trying to defend your decision, even though it's like in this form of educating somebody. Another trick I found works is you keep saying in this kind of discussion, this seemed like a good idea at the time. The way we did it, at the time it seemed like a good idea. It's probably maybe wrong. We didn't know better. So you kind of remove yourself emotionally from decisions that we made over the years. And that helps. That helps people think that way. If you keep saying it as a mantra, there is no need to defend some old decisions. The opposite thing that is also important is to stick clear of your core principles. So you don't have to defend every single decision. You should not defend everything. But there are certain things that are important and they have to be communicated clearly. For example, in Orleans, we stated that programming model and programmability is the top priority. Everything else comes second. Implementation, efficiency. If a programming model is messy, if there are 100 ways to do the same thing, that's bad. That's our priority. We're going to reject some of the ideas and improvements because we believe that's paramount to keep things simple, clear, as much as possible, as much as we can. The other thing is that when we just went open source, I personally expect that the community will start telling us which way we need to go. And I quickly learned that the community actually was expecting us to communicate the roadmap. So they want us to be clear about the roadmap, share their opinion and suggestions, and then follow that road if they agree with it. And again, it's important to be clear there. Sometimes it's hard to be, humiliation is not easy, humility is not easy. And you have to train your brain, I believe, to do that. That's why it's important to listen and ask and not assume when somebody starts saying something, it's very natural for us to jump, okay, I know what you're going to tell me, which may be right, may be wrong. And by doing these tricks, by asking questions, by phrasing your opinion differently and in a softer way, I personally learn whenever I comment on issues and pull requests to put a lot of I think, it seems to me, instead of being very assertive, saying this is the right thing or this will work, kind of by putting these caveats, that's my thinking at the time. It's not a decision of me, it's not a decision of the team, because that may be misread by people. And things like probably, likely, I believe those words that train your brain to be more open and less assertive and allows more space for people to contribute. The other thing is, a lot of things are very subtle, and a lot of things people do not say. And unfortunately, often they assume the worst. When there is distance, when there is written language, I've seen it many times. When somebody puts a comment and somebody gets upset, the person who put the comment says, there's nothing wrong with this comment. It's technically correct, and there was nothing emotional. But the way the person read on the end really made the person unhappy, maybe unwelcome, or this idea, nobody likes my idea. And the one way I found that works is to have face-to-face conversations. Skype helps here. When you start talking, you see faces associated with people that write these comments, you build trust, you build a better understanding. When somebody writes this, it's not against my idea, it's not against me. It's really to help everyone move forward. I think we're lucky. We had maybe like a couple of very limited tensions, but nothing major, and the community is very, very warm and welcome. That's what we're hearing. But it's important to stay on the lookout and see for signs of trouble. This challenge, I think we're still figuring out how to deal with. So there's a kind of two-tier system of maintainers and then contributors. And there aren't any clear rules we figured out how to do that. I mean, it seems like to promote somebody into contributor, the most important skills are their ability to review other people's contributions and maturity both on the technical and non-technical side. But those are very hard to measure qualities, and it's hard to communicate, and it's hard to see what the expectations are. If somebody contributed 30 PRs, they may be expecting that they're going to be made a maintainer, even though it's a very different set of qualities. If there are suggestions how to do it better, I would like to hear after the talk. There's a lot of talk about diversity in our community, and it's generally focused on kind of visible factors. But the thing that I see very rarely is talked about is just geographical diversity and cultural diversity when people work remotely on the same project. And you see this difference in kind of perception and conversation. For example, you see that I know some people, a lot of people from former Soviet Union, they tend to be very direct and very critical. So once you realize that's just a cultural thing, it's not that this person is more critical than others, it's just that's the way they do. They communicate. Like the Gabi Kliot, who we started this project with, he's being Israeli. He could kind of spot Israeli people like by just the way they phrase the question. Like, oh yeah, I see, that's a very familiar style. It's very kind of inquisitive and trying to kind of push the opinion. So it's important to be aware of that. It's important to understand that, for example, in China, people are very shy about the language. And I've seen like half of the issues people start write, they write, I'm sorry about my English. But then they write pretty perfect English or very good. So there's a lot of things that you don't see, but it's very difficult for them. So I think Ruben, actually, who's here, commented that you need to be mindful of the language you use and try to write comments in simpler non-ambiguous English. There is no need to be very eloquent and use fancy words. Keep it simple that this whole population will be comfortable reading and understanding it. I'm probably stating the obvious, but people come to the community because they find, oh, this tech is interesting. I want to use it and try to have questions. But what we discovered, people stay in the community regardless. They don't use, say, or lean some of them, for the company. They don't have time to use it, but they still want to stick around and chat with people and share their ideas, and we welcome that. And I think it's a very good sign when they come, and sometimes they post links to some interesting articles they would never have discovered. Sometimes they just discuss new ideas for some even startups, and that's okay. I think we shouldn't restrict to just the topic of the project. I think in one of the talks, maybe the first talk yesterday, it was mentioned it's very hard to promote open source at work. I found it's actually very easy. The way I did it, and I hired, I think, 5 people a year ago when I got a headcount, I would tell them, look, in a few years, your resume will be your probably GitHub handle, your account. People will look and see what you've done. So you can come here and work in open source and get paid for it. Instead of doing it on the weekends and nights, contributing some projects, It's your full-time job, and you're building your resume. I had no problem convincing people that's a good proposition. So if you haven't tried it at your company, I suggest you do. But also, another way I will explain it to my management, that it helps us stay open to other ideas. It's very easy to be in the bubble. Like there is notion of Redmond bubble, right, where you just talk with people that kind of on the same page and we work in the same way. Once you get out into open source, you see people that do things very differently. And that's what we learned early on, that a lot of people saying, oh, this is code smell. And we couldn't understand first. Oh, we're generating this nice code and factors. Like, no, I don't want to generate these factors to be generated. I just want it to be much simpler. So that helps you stay up to date and not make stupid mistakes sometimes. I've been managing people for, I think, over 10 years because I enjoy it, not because I had to, because I like kind of help see people grow and then mentor them and help their career. And people would come and ask, what about my next promotion? Like, how am I doing? Like, what about this level? So what I formulated for them, and I've been telling them for several years, is, look, the way to look at your promotion or your career is this way. The technical process in the company is never perfect. But look at it this way. The more people you have that think you're not an idiot, over time it adds up. Because non-job is your fun. They're going to stay in the company for 10, 15 years. The chance of that is very small. But the more people know that you're good, or you're dependent. And I put an idiot just because it's easy to remember. It's not a mental trick. Doesn't mean they think you're not an idiot, but it's easy to remember this way to exaggerate. In fact, what it means is they think, I think it resonates with Ted's talk on Sunday. They know that you're professional, they know that you're capable, and they know that you're good to work with. For example, you saw Katie's talk yesterday. So we worked with her 5 or 6 years ago on the Halo project. If you ask me what we worked specifically on, I would remember only the top level thing. I don't remember any specifics. It's years later. But I do remember that she was competent, she was very good to work with, and she was trying to do the right thing. So that's the definition that should be instead of not an idiot. So since then, if somebody asks me, how is Katie? I say, yep, that was a very good experience. I would suggest you work with her. So that's kind of all I wanted to share with you. Thank you. And these are my credentials.